So yan, magandang araw sa ating lahat. Again, this is Engineer Jom Digia and welcome back to my channel. So sa video na to ay meron tayo mga coaching notes under fluid mechanics. So ito ay 7 problem guys na sinolve ko na at ito ipapaliwanag ko sa inyo kung paano nakuha yung mga sagot sa bawat problems na naririto. Under fluid mechanics guys, maaari kasi lumabas ito sa inyong board exam. So hindi lang naman pang civil, pang mechanical din naman to. And also electrical and electronics engineering. So huwag natin patagalin pa. Simulan natin. Number 1, sabi dyan, how high does mercury barometer stands on a day when atmospheric pressure is 98.6 kilopascals, considering that the specific gravity of mercury is 13.6. So solution, paano ko ba siya sinolve? Una, binigay yung 98.6 kilopascals. Okay? Ang inihingi, height daw. How high does mercury barometer? So meaning, pressure pa rin ang hinihingi pero naka millimeters of mercury na siya. So itong 98.6 kilopascals na to, kinuha ko yung conversion niya papuntang millimeters of mercury. We all know na ang special conversion ng 1 atmospheric pressure is 101.325 kilopascals and then ang katumbas niya in millimeters of mercury is 760. So, multiply ko itong 98.6 kilopascals dito sa ratio ng 760 millimeters of mercury at saka ng 101.325 kilopascals. Na-cancel out si kilopascal, kaya nakuha natin yung unit is naka-millimeters of mercury. Nung kinalcue natin, yan, check natin sa calcue kung tama ba yung lumabas. So, 98.6 times 760 divided by 101.325. Ang lumabas is, yan, sakto, 739.56 millimeters of mercury. So, this is our final answer for this problem. Dako tayo sa ating next problem, problem number 2. So, problem number 2, a balloon having a mass of 400 kilograms remains suspended motionless in the air. If the air density is 1.29 kilograms per cubic meters, what is the volume of the balloon in cubic meters? So, solution, ang inihingi is the volume. May binigay na density. Yung density, ayan, 1.29 kilograms per cubic meters. May binigay na mass na 400 kilograms. So, ang formula for density is mass over volume. Dinerive natin ang formula ng volume galing dun sa equation na to, which is magiging mass over density. Kaya as we substitute, we have 400 kilograms, yun yung ating mass. Dinivide natin sa 1.29 kilogram mass per cubic meters. Nag-cancel out si cubic meters. Ang lalabas sa sagot natin ay naka cubic meters, which is unit ng volume. So check natin sa calcule kung tama ba yung lumabas dyan. So 400. Yan, 400 divided by 1.29. So, ang lumabas is 310.08 cubic meters. So, sakto siya doon sa ating nakuha sa calcule. Okay? So, this is the answer for problem number 2. Maaaring lumabas yan sa board exam ng civil, mechanical, electrical, and electronics. Okay? So, basic problem lang yan. Dako tayo sa ating problem number 3. So, problem number 3, what is the pressure at point A in the tank if H is 2 meters? So, we have our diagram here or system. Yan, meron daw tayong system dyan na may liquid. And then, yung point A is ito sa may tuldok. So, from point A, papuntang surface ng liquid mo, meron kang 2 meters na height. Ang sabi dyan, ano daw yung pressure dun sa point A na yon? So, solution para dyan, ang ginamit kong formula is pressure is equals to gamma times height. Okay, we assume that the liquid is water. Pag walang binanggit sa problem guys, kung anong klaseng liquid yon, assume natin na tubig yon. Okay, kaya ang gamma ng tubig is 9.81 kilonewtons per cubic meters and then we multiply sa given height which is 2 meters from the surface of the liquid papunta doon sa point A. Kaya 9.81 times 2, nakuha natin is 19.62. So, verify natin siya dito sa ating calcule. Solve natin. So, 9.81 times 2. nakuha natin is 19.62. Unit niya magiging kilopascals kasi magka-cancel out yung isang meter pati yung isang meter nasa baba. Kaya magiging kilonewton per square meters or kilopascal. So this is our final answer for this problem. Okay? So let's proceed to problem number 4. So problem number 4, what is the atmospheric pressure on a planet if the absolute pressure is 1000 kilopascals and the gauge pressure is 100 kilopascals? So solution for this, we all know that the general formula for pressure involving absolute, atmospheric, and gauge pressure is P-abs or P sub absolute is equals to P sub atmospheric plus P sub gauge. Kapag binanggit sa problem guys na vacuum pressure, assume natin na ang vacuum pressure is negative P gauge. Pero since wala namang binanggit sa problem na vacuum pressure yan, dito tayo mag-a-arrive sa pinaka formula na to. May binigay na absolute pressure which is 1,000. May binigay na gauge pressure which is 100 kilopascals. So both kilopascals sa kanilang unit. Ang hiningi is atmospheric pressure. So from this, ayan, in-arrive natin yung formula for atmospheric pressure. So P sub atmospheric pressure is equals to P sub absolute minus P sub gauge. Nilipat natin yung P gauge sa kabila. Kaya naging minus yan. So therefore, atmospheric pressure is equals to 1000 kilopascals. Ito yung ating absolute pressure. Minus natin dun yung P gauge natin na 100 kilopascals. So we arrive to our final answer which is the atmospheric pressure of 900 kilopascals for this problem. So napaka-basic na problem na yan. So lumalabas sa board exam din yan guys. So nawa ay napanood yung tong video na to. And maalala ninyo kung paano siya sinolve. Basic na basic lang yan. So, we proceed to our next problem. Problem number 5. So, problem number 5. In a hydraulic press, the large piston has a cross-sectional area, or A sub 1, of 200 square centimeters, and the small piston has a cross-sectional area, A sub 2, of 5 square centimeters. If the force applied is 250 newtons to the small piston, compute the force acting on the large piston. So, solution dyan guys, hindi ko na drawing eh. So, pero ang pinaka gagawin mo lang naman dyan is magkakaroon ka ng ratio proportion ng force and the area. Which is force over area is equals to pressure. So, pressure sa larger piston is equals to the pressure on the smaller piston. Okay, pinag-uusapan dito ang diameter. Kaya, ang hinihingi dyan, yung force down na acting sa large piston which is F sub 1. So, sinubstitute lang naman natin yung A sub 1 binigay, which is 200 square centimeters, ayun na yun. Tapos sa kabilang side, yung sa smaller part natin, sa smaller piston natin, which is 250 newtons daw yung nag-act doon na force, over the given area, which is A sub 2, alam naman natin, A sub 2 mas mababa, syempre, yung kanyang value ng kanyang diameter kasi smaller piston nga. So, 5 square centimeters, so cancel out square centimeter on both sides, matitira is newtons yung kanyang final answer. Kaya since naka-newtons yung ating sagot, yung ating sagot para sa F sub 1 or force acting on the large piston is also naka-newtons. Which is nakuha natin dyan, 10,000 newtons. Or pag pina-convert sa'yo sa mismong board exam, pag sa problem sinabi, convert mo lang into kilonewtons which is equal lang naman siya sa 10 kilonewtons. So basic na basic ang problem na to. Proceed tayo sa ating next problem, problem number 6. So for problem number 6, the density of water is typically taken to be 62.4 pound mass per cubic foot for engineering problems where greater accuracy is not required. What is the value in slugs per cubic foot or cubic feet? Solution for this, guys, density is mass over volume. So yung pound mass, mass na yon. Yung volume dyan is yung cubic feet or cubic foot. So yung 62.4, yun na kasi yung given na density ng tubig. Ko-convert lang naman papuntang slugs per cubic foot. So yung cubic foot, matitira lang siya. Ang mako-convert lang is yung pound mass nun magiging slug. So we all know that in engineering principles or conversions, in one slug we have 32.2 pound mass. So basic na basic, dinivide lang natin yung 1 slug papuntang 32.2 pound mass. Kinancel yung pound mass. Kaya yung 62.4 mo, dinivide sa 32.2. So, calculate natin para sure. So, 62.2 divided by 62.4 divided by 32.2. Lalabas natin na density na naka-slugs per cubic foot or cubic feet is 1.94 slugs per cubic feet. So, basic na problem. Again, pakadali lang yan. So, proceed tayo sa ating last problem for coaching notes in fluid mechanics. So, for our last problem, if a depth of liquid of 1 meter causes a pressure of 7 kilopascals, what is the specific gravity of the liquid? So, solution for this, may binigay na pressure, guys. Okay? Tapos may height na 1 meter. We all know that involving pressure and height, kasama dyan ang specific weight. So, pressure is equal to specific weight of the liquid multiplied by the height. So, wala namang binanggit sa problem, guys, kung anong klase ng liquid yon. So, syempre, ang hinihingi sa'yo is specific gravity. So, therefore, specific gravity ng liquid. I-multiply mo sa standard na specific weight, which is specific weight ng tubig, which is 9.81. Yun, nandito. And then, you multiply by height. So, therefore, as we derive the formula for the specific gravity ng liquid, so, Sg sub L is equals to P, yung pressure na binigay, divided by the gamma of the water multiplied by the height. So, kasi, malilipat sa kabila yan, pati ito, madidivide. Okay, matitira sa kabila to, and then, kaya magiging ganito yung equation mo. So, therefore, Sg ng liquid is equals to 7 kilopascals. Yung kilopascal, guys, naging kilonewtons per square meter. Yan yung conversion niya. Kapag nire-write mo siya na maayos. Divided by 9.81. Yung 9.81, guys, again, gaya na sinabi ko kanina, yun yung specific weight ng tubig or gamma ng tubig, which is kilonewtons per cubic meters na kanyang unit. Multiplied by the height, given yung height na 1 meter, ayan yon, kaya dinivide din sa 1 meter. Nag-cancel yung meter, naging kilonewton per square meter yung baba as well as yung taas, kaya nag-cancel sila parehas. Therefore, yung ating specific gravity ng liquid is unitless. So, check natin sa calculus kung tama ba yung 0.714 na yan. So, 7 divided by 9.81. So, lalabas is 0.714 ang ating specific gravity ng liquid, which is unitless. So, basic na basic, di ba, guys? So, itong mga problems na to, again, problems 1 to 7, lagi lumalabas sa board exam ng engineering under fluid mechanics. So, nawa, kung napanood yung video na to, maalala ninyo kung paano siya sinolve, basic na basic lang naman yung principle sa inyo. At nawa, pag na-encounter nyo mismo yung problem na yan, kahit di na kayo mag-solve, tandaan nyo na lang yung final answer. Looks from nyo na lang kaagad. So, para mas mag-focus kayo doon sa mas mahihirap na problems na maaaring lumabas sa board exam, even in the exam in your school. Okay? So, kung may mga katanungan kayo, maaari kayo mag-message sa akin through FB, and pwede nyo akong i-email, or comment down below na lang para mas masagot natin inyong mga katanungan regarding fluid mechanics. Again, this is Engineer Jom Digia. Nawa may tutunan kayo sa ating pinag-aralan ngayong gabi. God bless us all.